Good morning, boys and girls. Okay, let us move to the next topic, that is electric current. Okay, all substances are made of atoms. You must have studied in chemistry. Okay, so atom consists of a nucleus having proton and neutron, and electron revolves around it. You know that. Okay, so in metals, what happens? Metals are the good conductors of electricity. So metals have positive ions in the nucleus, and the electrons revolve around it, and they are free to move here and there. So within the metal, they cannot go outside, but they move within the metal in all directions. There is not a set direction for them. So they move in all directions. But when current is supplied, it is connected to a battery or an electric source, that means current is supplied, that means electrons are supplied. Actually, flow of electrons is current. So some electrons enter into the wire, and they push the electrons in a particular direction. Okay, so thus the arrangement is made within the wire. So all electrons start moving in the same direction, and a continuous flow is there. That's called the electric current. Okay. So the amount of electron flowing per unit time, that is per second, we can measure the current. Okay, it's just like here, it's given. The water flowing, okay, so water can flow very fast or very slow, or it can be, amount of water can be more or less. So that's how current and voltage depend upon. Okay. Now sources of electricity. There are different sources. Okay, like battery, cell, and power stations, all are sources. So what is the source? Actually, source means it's an arrangement which brings a force, that is EMF, which pushes the electrons, that is electromotive force. Okay, so which sets the direction of free electrons, and it current starts flowing because of that force. Okay, so in other words, you can say some form of energy is converted into electrical energy. Okay, it can be like in dams, electricity is produced, or maybe in generators or whatever. So now you can see here in the book given, a cell, a battery, and a generator. These three common sources are there. Okay, what is a cell now? A cell is an arrangement in which chemical energy is converted into electrical energy. So in a cell, a chemical reaction goes on, okay, where electrical energy is produced. Okay, all in a cell. In detail, if you go in later classes, you'll go. All electrons and the positive ions are collected at the poles, and when a circuit is joined, the electrons start flowing into through the circuit from one end to the other end. That's how the current flows in the cell. Now cells are of two types, primary and secondary. In primary cells, cells are once used. That means the chemical reaction over there is complete and they cannot be used again. But in secondary cell, they can be used again. That means the chemical reaction can be reversed over there and it can be used again. So two types of cell are there. And battery, a combination of cells is called battery, so it's not different. In daily use, you must have seen these batteries are used in inverters and other devices like computers and all. And on mobile phones, these batteries are used. Now, resistance means resistors, those which limits or regulates the flow of flow of electric current. Okay. So actually it makes current, it's an obstacle for the current. Okay, so that's how it controls the current to flow. Okay, so it is used, resistors are of different types, different for different uses. They are made of mainly carbon metal or carbon oxide film. Okay, so now symbol of electric components. You can see here in the table. This is cell, and a combination of these cells here is battery. Then bulb, this is the symbol used. And switch, like this. This is a closed switch. Closed means the current is passing through it. And this is an open switch. When switch is off, this is off position, this is on position, and this is a wire, and this is resistance. Now electric circuit, an arrangement through which electric current flows is called electric circuit. Okay, so there should be a source of current and there should be a device or a device used and a switch. So these three, when joined together by a wire, that is called an electric circuit. Okay, so this here in a torch there is a simple electric circuit. Okay, this is a cell, source of electricity, and a wire is joining here and switch is here and a bulb is here, and through bulb the current, it is joined to the battery, the positive pole of the battery. So now when switch is on, current starts flowing from here and the bulb glows and the circuit is complete. Okay, now resistance. What is resistance? Resistance I have already explained here. So they can be joined in series and parallel. Two types of combinations are there. So series means it is joined here one end, the other end on the here, and from this end the next resistance, then the next resistance, same way, and it is completing the coming to negative end of the battery. So there is only one path for the current to flow. Okay, here in this series, the voltage is decreased, but the current remains the same. Okay, in this combination. But here, in parallel combination, parallel is joined like this. From here, the current is one is here and here. So circuit is complete for this also, and again one wire is going for this also and this also. Now here the current is divided. Okay, the current does not remain the same, but the voltage remains the same. Okay, so that's the difference here in series and this parallel. Okay, here voltage remains the same and here current remains the same. Now, good and bad conductors. Okay, almost most of the metals are good conductors of electricity. Okay, those metals which do not conduct electricity easily, they are called the resistance. Okay, so some very good conductors are, the best is silver, then copper, aluminum, like that. Okay, so these are some of the best conductors of electricity. Now insulators already are which do not pass electricity through them. So they have very high resistance, in other words you can say. So rubber, glass, porcelain, these are some of the bad conductors. Now you are all studying about electric current, but it can be very dangerous when we get in contact with electricity, especially when it's very high voltage. Okay, so we need to take some precautions. What precautions? We should use high quality wires. Okay, not low quality wires, having a very good insulators over there, and we should cover all the joints with insulating tape. No naked wires should be there in our homes. All connections and plugs must be very tight, should not be loose, because loose connections may spark and catch fire, or also may come in contact with us. Okay, and we should never touch any electric circuit or a part of it without having a rubber shoe. Okay, or a rubber gloves also we should. When we handle, we should use rubber gloves, because rubber shoes are bad conductors. So the current does not pass to the earth and circuit breaks. So it's necessary to wear rubber shoes, and if you wear rubber gloves, so it will not go through your hands also. So those are the precautions you should take. Okay, now you try to find out question and answers. Okay, short, long, and tick the correct. You can leave it. Okay, leave it, and then you have to do. Okay, fill-ups you do. Definitions you have to do. True, false you can do, and leave it. You don't do. Matching you have to do. Then this one you have to do. Okay, so try to find the answers. If you don't get the answers, contact me. Okay, call me. You can call me.